We are looking at 12.1 second day. We'll start you off a little bit easier today, and then we're going to get you some challenging problems, as we always do with the second day of a section. So as you look at it, we're still in conics. If you recall the equation of circle that we reviewed yesterday, so we have x minus h squared plus y minus k quantity squared equals r squared. Again, that occurs when the center is located at h comma k, and your radius is equal to r. All right, so we're going to take a look at completing the square because we're going to need that in order to do the next part for today. So if you remember, x squared minus 6x plus 8 blank, that's we're trying to figure out what to put in that blank spot so we could factor and make it a perfect square. So in order to do that, if you remember, we have that simple equation of 1/2 whatever the b value is, and then we are going to square it. So if we take a look at this example, we would do x squared minus 6x plus blank. And what I'm also going to do is I'm going to put a minus a blank because we have to make sure we balance out our expression in this instance. So if I were to go off to the side here and I were to use this idea, I would say that I would take 1/2 of where our b value is the 6 or -6. It was not going to matter because eventually we are just going to square it. So if I take 1/2 of -6, I get -3 squared. I'm going to get a +9. And then again, as I was saying, we want to balance the expression. So since we add a 9, we are also going to subtract 9. Now, the reason why we do this is these first three terms, if we group them together, we could factor that into x, we can factor that into x minus 3 squared, and then the -9 is just hanging out because he was there in order to balance out the equation. And that is what our answer is going to look like if we were just completing the square on an expression. If we take it up a notch, we can also do completing the square on an equation. And what I'm going to do first is I'm going to move the +4 correctly to the other side and make it a -4. And now again, to figure out what I want to add in this blank, I'm going to take 1/2 of the b value. In this case, the b value is a +12, and then I want to square it. So if I were to take 1/2 of 12, right, I would have 6. 6 squared would give me 36. But again, this is a little different because in equation, if you add 36 to one side of the equation, you have to add the same amount to the other side in order to make sure it's balanced. So once I add the 36s to both sides, now I can look and say, all right, well, if I want to factor the left side, I could have x plus 6 quantity squared. And the nice thing is that number that's inside there is always the number before you squared it. So 1/2 of 12 gave me a 6 plus 6. On the previous example, I had 1/2 of -6 was -3, and so it kind of went into parentheses. That's a quick way you can look as you do your factoring. Should work out each time. So that's going to be equal to, well, I get 32. Now, if it just said I want you to complete the square, you are done right here because technically we did complete the square. But I have a feeling they're going to want you to go a little further, and they're going to say solve by completing the square. So let's review that concept here. So make sure you read the directions carefully. If I had to solve by completing the square, this is where I would take the square root of both sides, right? Square root. And I'm going to say, well, the square of the left-hand side just gives me x plus 6. The square of the right-hand side, well, make sure you remember to put plus or minus. 32 can be broken down into 16 and 2. So I have 4 radical 2. So ultimately, I would get that x is equal to -6 plus or minus 4 radical 2. Again, that's if the direction said solving. If it doesn't say solving, then you wouldn't have to go that far. You would just stop where I had before I started, square rooting both sides and going from there. Okay? So that's just the basic concept of completing the square. Now, why do we use that? A perfect example is if we want to get a circle equation, or we want to get a circle into standard form, what we can do is we can use completing the square in order to help us do that. Now I'm purposely going to leave a space, y squared plus 2y, leave a space, equals 15. So on this first group, what I'm going to do, and we'll mix and match little colors a little bit, same thing we've been doing. I'm going to say, all right, well, what is 1/2 of -4, well, that'd be -2 squared would be +4. In order to balance, I'm also going to add the +4 onto the other side, right? Because we're looking to balance our equations each time we do this. Now the next thing, if I say okay, if I add, well, if I take 1/2 of 2, which would be 1, squared, that's going to stay a 1. And again, I want to balance, so I'm going to put it as a +1 onto the other side. All right, so now the reason why we did that is this is where we can factor our quantities and say x minus 2 quantity squared plus y plus 1 quantity squared is equal to 20. And you see how we have that standard form equation that we talked about on the very top of the paper up there. Okay, and that's the standard form that we're looking for. So we found the equation, right? I guess I can put an arrow right there because we filled in right there. The center, good practice from yesterday. Take the opposite of the first group, take the opposite of the second group, and the radius would just be the square root of 20, or if you simplify that, 2 square root of 5. Okay, so that's all we're doing. We're completing the square. This case we had to do it twice because we had an x squared, an x term, a y squared, and a y term. We need to make sure we do it twice in order to get it into the exact standard form for the equation of a circle. All right, so let's do it again. So again, I'm going to say x squared plus 8x. I'm going to leave a space, plus y squared minus 6y, leave a space, equals 50. So if I were to go through and say this first group, well, if I were to take half of 8 would be 4, squared would give me a 16. And again, I want to balance, so I'm going to put a plus 16 over there, just balancing out my equation. If I look at my second group that I have with the y's, because I have a y squared and a y term, I would say 1/2 of -6 is -3, squared gives me a positive 9. Again, I want to make sure that I balance out my equation. So I put the positive 9 onto the other side. So now my equation just simply means just take this first group and factor it. So it simply just becomes x plus 4 quantity squared plus, again, take this group, factor it. And the whole idea is, right, is completing the square. It's got to be a perfect square group. If it's not a perfect square group, you made a mistake. Go back and fix it. So if I factor that, y minus 3 squared equals, if I add all my information together, I'm going to get 75. So now if I look at my nice simplified in standard form equation, I can simply say, oh, well, the center of the circle, that would just be -4, +3. If I take the square root of 75, that would give my radius, or obviously you can simplify that to 5 radical 3. Okay, so there's just some simple information or simple problems for finding the equation of a circle, practicing you're completing the square in order to get it in the ideal form that we're looking for to get our information of the center and the radius. All right, let's look at some other practice problems. Now this one's asking me to find the center of the circle and the radius if the circle goes through and it gives me 3 points. So I get -12, 1, 2, 1, and 0, 7. So what I'm going to do is this, is I don't know what the center is, so I'm just going to call the center H, comma K, because I don't know what it is. So let's call it that, okay? And I don't know what the radius is, so obviously we're going to let the radius just be equal to R. Now, if I were to take this first point here, let's call it point A, and let's say if I made an equation, or if you may need to, write it down again, x minus h squared plus y minus k squared equals r squared. We're going to use that a lot in this problem. So if I look over here and I were to take -12, 1, well, I could call that an x and a y that's on the circle. So what I can do is I can replace this x and this y with -12 and 1. And I can make it -12. I don't know what h is, so I'm going to leave it as minus h. That's the goal we're trying to find. Plus, well, my y value is 1 minus k squared. And again, I don't know what the radius is, so I'm going to leave it like that. Okay, and if you wanted to, what you could do is you go through and simplify it, right? Expand it out, FOIL it out, multiply it out. 144 plus 24h, careful all those negatives there, plus h squared plus 1 minus 2k plus k squared equals r squared. You can take a step further and simplify, but don't need to right at this moment, but we'll get back to that in just a second. All right, so there I took the point A, I called it, and I just plugged it into the standard form of the equation of the circle with the x and the y, because I know that's the x and the y. That's not the h and the k, so be careful. If I call this point B, right, and again, this is the x and the y. So what I can do, using the 2, 1, or coordinate B, I'm calling it in this case, I can do the same thing where I can go through and say 2 minus h quantity squared, again, because this is the x coordinate is 2 of the point, not the center, plus 1 minus k squared equals r squared. So if I clean this up, I got a 4 minus 4h plus h squared plus 1 minus 2k plus k squared equals r squared. Okay, so there's again is an equation that would have coordinate 2, 1 on the circle, but I don't know the h, the k's, and the r's yet, so I'm going to leave that on purpose. We'll come back to that in a second. All right, might as well. We're going to roll right here. So let's call this coordinate C. Do the exact same thing with 0 and 7. So I'm going to say 0 because that's the x coordinate and the y coordinate. It's not the h and the k. You have to realize that, okay? So I have 0 minus h squared plus 7 minus k squared equals r squared. So again, if I want to clean things up, I just got a nice, oh, that's nice, just h squared from that group, plus 49 minus 14k plus k squared equals r squared. So again, just going through and making sure you're careful with your multiplication groups, you know, and just being careful. You know, you can rearrange this if you need to. I don't really need to because I'm going to show you what's going to happen here. All right, so thinking back to algebra, we have 3 variables, h, k, and r. We have 3 equations, equation A, equation B, equation C. So what I want to do is just do a big substitution to go ahead and try and solve for the different variables. So I'm going to start off with, let's see if I just start off with A and B. If you remember from algebra class, it doesn't really matter where you start. Just pick 2 of the equations. The nice thing is that in both of these equations, they equal r squared. So if you think about it, if you do substitution, since they both equal r squared, I can set them equal to each other. So I can take equation A, which was, well, I'm going to combine it, 144 plus 1 gives me 145 plus 24h plus h squared. Remember, I put the 1 with the 144 to make 145 minus 2k plus k squared. Now remember, the r is gone because I'm letting this equal the b equation, which if I get the 4 and the 1, that makes 5 minus 4h plus h squared, getting tight here, minus 2k plus k squared. Ooh, got a little tight there at the end. But all I do is I just set the 2 equal to each other. That's how you do systems of equations, right? You have 2 equations, or 3 equations, in this case 2 equations, multiple variables. They both equaled r squared, so I set the 2 equal to each other. Now I'm just going to look to clean things up. And the nice thing is, because I have a plus h squared and a plus h squared on both sides, they'll cancel. Oh, look, minus 2k will cancel with that minus 2k because they're on opposite sides. And then k squared will cancel with that k squared. So ultimately, this reduces to 145 plus 24h equals 5 minus 4h. And what I can do is I can now add the 4h over to get 28h, because all I have is h's left, right, and numbers. Subtract the 145 and get negative 140. And if I divide and solve, I just get that h is negative 5. And what that just tells me is that the x coordinate of the center is negative 5. So h is negative. That gives me the x coordinate. Okay? So what I want to do now is I have one of the variables. I still got to get 2 more. what I can take that negative 5, and I'm going to actually make a new equation. Well, we'll make a different color. We'll go green. And I'm going to put B and C together, because the nice thing is they both equal R squared. I can do like I just talked about when I put A and B together. But I'm going to do two things here. Is I'm going to make those two equations equal each other, and I already know what H is. I already know that I just figured out that H is negative 5. So I don't need to go through and leave a bunch of H's in there, because that makes it more confusing. Let's start doing some some substitution. So if I were to take my equation, I'm going to say I have 4. Now here I have minus 4 times negative 5, because I'm substituting the negative 5 in for the H, plus, well, I have negative 5 squared, so that becomes 25, plus 1. I don't know what k is, so I got to leave that. Negative 2k plus k squared. What I'm also going to do is I'm going to take that negative 5 and use the C equation. So if I plug in negative 5 for the H squared, I'm going to make that equal to 25. Again, I can make the two equations equal because they both equal R squared. So I'm just doing substitution. They both equal R squared, so I'm making the rest of the pieces, setting them equal to each other. So if I plug in negative 5, I get H squared. Sorry, I would get H squared is 25. So plus 49 minus 14k. Run out of room again here. Gotta give myself more room. Write a little smaller. Plus k squared. So all I did was I plugged in the negative 5 into both equations B and C, and I set them equal to each other because they both equaled R squared. That's just substitution like you learned in Algebra 1 class. Okay? So now, if I clean things up a little bit, I have 4 plus 20 plus 25 plus 1 minus 2k. One thing I noticed is they both have a k squared on both sides, so I might as well get rid of that right now, right? Knock that guy out. Equals 25 plus 49 minus 14k. So if I clean things up a little bit here, there's a 25. I can add stuff together. So if I add stuff on the left-hand side, I am going to get a nice 50 minus 2k is equal to, what's that? 74 minus 14k, right? Just adding that together. No need for a calculator. You got your brains, right? That's your big calculator. And so then I can go through, if I were to add 14k, because you're doing correct algebra, I'm going to have 12k is equal to 24. Oh, nice. A lot of times these numbers won't come out nice. In this case, they did for us. So we got k equals 2. So what does that mean? That means that we know that our center of our circle is going to be at negative 5, comma 2. That's what that's telling us. Okay, so we found out what the center is. We got negative 5 and 2. The last thing we need to do is we got to find out what the radius is. So we use different color. Why don't we use a nice red? Finish this guy up. So what I'm going to do is just take equation C. You can pick whatever you wanted. You can pick whatever equation you want. I just picked C because it's got the least amount of variables. And I'm just going to plug in negative 5, positive 2 into my equation C and then solve for R because we need the radius. So I'm going to say H squared. We know that's 25 plus 49. So I have negative 14 times 2 gives me negative 28. Remember, all I'm just plugging in is 2 into that equation, just like I plugged in negative 5 into that equation. Okay? Plus, well, I have 2 squared gives me 4, and that's going to be equal to R squared. So all I did is I just used the C equation, plugged in the variables that I've already solved for, just like algebra class, plugged them in, trying to solve and go from there. Okay, so when I look at this, this left-hand side, well, that becomes 50, right? Double check my adding skills right there. I believe that's 50 equals R squared. So then I know that my radius is just going to be the square root of 50, or typically simplified 5 radical 2. Okay, and that's what I was asking for. So I was asking for what are the coordinates. Probably should do is clean that up a little bit, right? What haven't we used yet? How about a nice black, right? Okay, so I'm going to go here. I'm going to say, all right, I have negative 5 comma 2. That is the center of my circle. Negative 5 comma 2. And 5 radical 2 would be my radius. Okay, so there we go. A little bit of a challenging problem, but a lot of it's just algebra. 3 variables, 3 equations. Go through and do your substitution, all the stuff that you need in order to simplify as far down as you can. Get a variable, plug it back in, put more equations together until finally you get all 3 variables. Okay, so negative 5 comma 2 is the center, and then 5 radical 2 was your radius. Whew, told you a little more challenging today. All right, let's take a look at the next side. Number 2. Okay, it's telling me the point 63 is the midpoint of a chord of the circle, and it gives you the equation. Find the length of the chord. So what I'm going to do is let's write down what we know. Well, based on this, I know that my center is at 6 comma 6, and I know that my radius is 6. So if we think about this, like I said before, I'm a visual learner. So if we were to graph this, give myself a little more room in that first quadrant. That's a little better. All right, so if I go 6 to the right, 6 up, so right about there, I can see as my center. The nice thing is the radius of 6, that means that the circle is going to hit the axes right there and right there. That worked out pretty nice. It's not drawn great. I hope yours is drawn much better, right? So 0.63 is the midpoint of the chord. So if I go 6,3, it's right about there. That means that my chord would have to go through here because that's the midpoint. If you remember back from geometry class, if you draw from the center to the midpoint of a chord, it bisects that chord and it's perpendicular. So you get a lot of good review there from geometry class right there to help you out in this problem here. All right, so, well, we got to find the length of that chord. Oh, I don't know what part of it. I can call this x, and then we said it got bisected, so that's also x. Well, let's use this idea. If this is at 6, 6, if the center is at 6, 6, and the midpoint of the chord is at 6, 3, that means that I know that the space from the center to the midpoint is 3 units. And what I can also do is I can draw the radius and draw it to a good spot. I can draw it all the way out to where the chord hits the circle. Why? Well, because if I know the radius is 6, I can put that into my diagram. And now if I take that piece out, maybe it's getting a little crowded there. If I take that piece out, it looks like this. Right? I have a 3 and a 6 and an x right there. Well, I got a nice easy right triangle. So I can just go through and do x squared plus 3 squared equals 6 squared. If I solve carefully, so x squared plus 9 is 36. So I get that x is going to be the square root of 27 or 3 radical 3. But now that's what x is. Remember, x was only this piece here. Okay, like I said, if you remember from geometry class, the midpoint of a chord, so if you go from the center to the midpoint, it bisects it. So if I want to find the length of the whole chord, I have to double it. So it would be 2 times 3 radical 3, and I'm going to get a whole length of 6 radical 3. Didn't give me units, so I can just leave it as 6 radical 3. Okay? All right, so there we go. Now, that wasn't so bad, right? Just got to remember a little geometry from back in the day. But you guys remember that's usually real good. Okay, number 3. This is a little bit of a trickier one. Find the area of the triangle with these 3 vertices. Okay, so my suggestion, let's draw a picture. Let's see what's going on over here. So if I start off like this, I have negative 3, 3. I'm just going to call that A, right? Might as well give it a name, right? Start A for the alphabet. Okay, 1, 2, so right about there. We can call that point B. And then 0, negative 5, somewhere down here. We'll call that C. Okay, so I got this, and I have this, and I got this. There we go. It's not straight lines, but I'm sure you can draw better than I did. All right, so what I want to do is I want to go through and I want to find the area of that triangle. Okay, so if I were to go through and do that, right, let's get rid of that. That really looked really bad. Oops. You got a couple ways you can do this, right? You can, if you wanted to go back and use Heron's formula, that's one way you could do it, right? Find all the side lengths and then kind of go from there. Another way that I saw you can do is if we use the stuff that we learned in day 1 of this chapter. If I were to go through And if I were to find, so I'm going to do a little process over here. Now, step number one is I'm going to find the length of AC. And you can start whichever line you want to. I figured AC, we'll just start with that one, okay? So if I want to find the length of AC, well, to find the length of it, that's just another way of just saying find the distance between those 2 points. And you go back and look at your notes if you need to, or you've memorized the formula for distance. So we're going to say -3 minus 0 squared plus 3 plus 5 squared. That's just some distance formula. Hopefully you practiced that last night when you're doing your homework. And if I were to clean this up, I have 9 plus 64. I'm going to get the square root of 73. So I know that the length of that line is equal to the square root of 73. Okay? Now, the next thing I'm going to do is, if I look here, is I'm going to find the equation of AC. And the reason why is because, if you remember, for areas of triangles, we want to try and get a side and its perpendicular height. Well, we talked yesterday about finding the distance from a point to a line, right? So if I could go through, and if I eventually are going to find the distance here, look at, I will have my perpendicular that I'm looking for between a base and a height, and I can find my easy formula, right? All right, so that's kind of the path we're going to. Okay, so back to the problem. So this helped me get number one. To look at number two, I want to find the equation of AC. In order to find the equation of a line, we talked about that you need to find the slope. So if I want to find the slope of AC, well, that's just your slope formula that we reviewed, right? So you got -5 minus 3 over 0 plus 3. So ultimately, you have the slope of -8/3. The nice thing is 0, -5 is a y-intercept. So if I have a slope, I have a y-intercept, I know that I can just say that the equation for AC is simply just going to be y equals -8/3 x minus 5. And there is my equation for AC. Now, as we said, as I was talking about earlier, now that I know the equation of AC, I have the equation of a line, I can now find the distance from AC to B. So I can now find that distance to get from AC to B there. So, right, if you may have to go look at your notes for the distance formula, D, I guess we're using lowercase, that might be consistent. D equals, now because it's in slope-intercept form, I'm going to use the one that was the first equation I gave you yesterday, was mx plus b minus y over the square root of 1 plus m squared. So if I were to go here, I'm going to start plugging some information in. The absolute value, I know that my slope is -8/3. I know that my x value, right, now we're doing it towards B here. So in this case, 1, 2 is my coordinate, so my x is going to be 1 because I'm finding it to B, right? That was 1, 2. Plus my B value is -5 minus the y value of that coordinate, so minus the 2, and that's all absolute value, all over the square root, getting a little messy here, but be ready, 1 plus -8/3 squared. So now I got to do some simplifying here, right? So scoot this up a little bit. So if I simplify that, well, if I look in the numerator, I have -8/3 minus 7. Get your common denominator. Make that, that's going to come out to be with the absolute value, 29/3. Don't take my word for it. If you're not sure, then go ahead and check it. Don't just automatically assume. Make sure I'm doing it right. Okay, square root. Now I got to, again, clean up that bottom. If you look here, right, this helps a little bit. You have the square root of 1 plus, that's going to be 64/9. So ultimately, you're going to have this, if you get common denominator, you're going to have 73/9, or you're going to get the square root of 73 over 3, because all I did was I simplified the square root, right? Some of you may be thinking too fast. Then let's do this. 73 over the square root of 9. When I add those two numbers together, get common denominator if you need to. Okay, so now I can go through and say this is the same thing as 29 thirds times the reciprocal, 3 over the square root of 73. The nice thing is those cancels. So I know that the distance is 29 over the square root of 73. That would be the distance from AC to B, right? 29 over the square root of 73. That, if you go back to our diagram up here, that's the blue line that's up there. That's the distance from AC to B. So my last thing now is I just want to find the area of triangle ABC, right? That's all we got to do. And that's simply just going to be 1/2 the base. Well, because they're perpendicular, we can let AC be the base. And from part 1, we found that the length of AC was the square root of 73. And then from part 3, we found that the height, the perpendicular height, is 29 over the square root of 73. So if you look nice and neat, oh look, these cancel. So ultimately, I'm just going to get 29 halves as the area of that particular triangle. Okay? So got some more challenging problems today. Oh, it always happens in the second day of a section. Good luck today. Make sure you ask your teacher questions if you have them. All right, bye.